morning. My name is Dr. K. Lalithambigai, Assistant Professor, Department of Physics, KSR, College of Engineering, Tiruchengodu. Today we are going to see the experiment determination of the divergence of the laser beam. You can see here one screen, one laser source, 1 meter scale and optical bench. So this is screen. The screen covered with one graph sheet. Okay. Now we are going to see one of the special properties of laser beam is less divergence or negligible divergence. From this experiment, we find the angular divergence. So the formula for the angular divergence of the laser beam is theta is equal to A2 minus A1 divided by D2 minus D1. The final answer will be in radians. So the above formula have different letters. So let us consider the letter A1 is the diameter of the laser spot at position 1. Then A2 is the diameter of the laser spot at position 2. Then D1 is the distance of the position 1 of the laser spot. Then D2 is the distance of the position 2 of the laser spot. All the letters have the unit in meter. Here, the figure 1 represents laser source generate this spot A1 at the distance D1. From this experiment, we find the D values. It means distance between the laser beam and the screen. Then we find the A values. It means diameter of the spot horizontally and vertically. Mentioned values are noted in this tabular column. Then finally, we find the angular divergence theta for given laser source. Let us start. The laser beam is allowed to fall on the screen and the spot of the beam is observed and the spot sides of the beam is measured. First we kept the laser source at the distance 20 cm between the screen and the laser source. For the 20 cm distance, the laser beam is permitted to fall on the screen and the spot of the beam is observed and the spot sides of the beam is measured. It means marked on the generated spot size. So just we mark by using pencil. We marked it, then we measure the horizontal lines and vertical lines of the generated spot. The generated spot is in circular shape, so the horizontal lines and vertical lines obviously will be same. So we just mark the horizontal lines. It means we count the horizontal lines and vertical lines one by one. If the horizontal lines are 4 means the vertical lines will be the same. So we count the horizontal lines. We just put the same value for the vertical lines. Now we count the horizontal lines by using this graph sheet. Then we noted the tabular column. For the 20 cm distance, we just mark on the lines. It has 4 lines. It means 0.4 cm. Then we increase the distance from 20 cm to 40 cm. The laser beam is allowed to fall on the screen and the spot of the beam is observed and the spot of the beam is measured again for the 40 cm distance. Now we measure the lines horizontally one by one. It means it has the lines, 5 lines. It means 0.5 cm are noted in the tabular column. Let us check the spot vertically has 5 lines or not. Just we count vertically one by one. It has 5 lines. Now we increase the distance from 40 cm to 60 cm. Now we fix it. So now we can adjust. Then the laser beam is allowed to fall on the screen and the spot of the beam is observed and the spot size of the beam is measured again for using the same procedure for the 20 cm distance and 40 cm distance. Now we mark on the spot. Then we count the horizontal lines one by one. It has 6 lines. It means 0.6 cm. Additionally, we check lines one by one in vertically also. Now we increase the distance from 60 centimeter to 80 centimeter. Then we follow the same procedure for previous one. Then we noted the generated spot size horizontally one by one. Now we increase the distance from 80 centimeter to 100 centimeter. It means 1 meter. So the laser beam is allowed to fall on the screen. And the spot of the beam is observed and the spot size of the beam is measured horizontally one by one. Now we switch off the laser source. Then we noted the readings for the finding determination of the divergence of the laser beam for the given tabular column. So we noted the taken readings one by one. First we noted the distance between the screen and the laser source. So we have taken 20 centimeter, 40 centimeter, 60 centimeter, 80 centimeter and 100 centimeter. Now we add the diameter of the spot horizontally and vertically readings one by one. So substitute these values in the formula A2 minus A1 divided by D2 minus D1. But we have only D and A values. So now we consider as first distance 20 centimeter have D1 and second distance 40 centimeter have the D2. The same for the diameter of the spot A1, A2 and substitute these values in this formula A2 minus A1 and D2 minus D1. So A2 is the value for 0.5 and A1 is the value for 0.4. Then D2 is 40 centimeter and D1 is the 20 centimeter. So we substitute these values in this formula. Now we get 0.5 minus 0.4 has 0.1 and 40 minus 20 has 20. So finally we get 0.1 divided by 20 has 0.005. It means 5 into 10 to the power minus 3. For the given laser source, the laser divergence has 5 milliradians. So it means 0.005 radians. Also we find the laser divergence of theta values from other set of values for using this same procedure. So finally we prove the laser has less divergence. Now we are going to see the possible Viva wise questions for this experiment. Thank you.